Okay, so this is part two. Now we're looking at number 9. Open the sampling words applet. Make sure the variable is set to length. Check the show sampling options box. Change the sample size to 5 and press draw samples. So we would find that. One way to find it is on Canvas. Click the applets. That'll take you to here. Click the sampling words because that's the one they're talking about. And when you click on that, you'll end up here. And so then make sure that it's on length. And then we're going to click Show Sampling Options. And I'm going to scoot over here. And then these numbers are from the last time I did it. So you would have seen it when you did this. Your first time would show up as 10, but you need to change it to 5. And so draw samples. So there we go. We've got, this shows like the whole sample. And this shows a histogram of all of the sample statistics. In this case, I've only done one sample, so it's pretty boring. Okay, so moving ahead here, for number 9, it just told us to do stuff. It didn't ask us for anything. So for number 10, if we were to repeat the process number 9 thousands of times, predict the behavior of the distribution of sample means, the graph of all the ways to the right of the applet. Shape, center, variability, compared to the population. So this is, don't worry about so much about being precisely right. Just give us a good guess because you're about to find out in the next couple ones. Okay. So then once you've done number 10, then change the number of samples from 1 to 9,999. So 9,999. And then we are going to draw samples. And so now that's my most recent sample. That's the number that goes with it, and then that number got put over here. And so then create a sketch of the distribution box below. So create a sketch of it, including carefully labeling the horizontal axis and indicating what each dot on the graph represents. So like by dots mean like what's in these bins for the histogram meaning. Like how, and then tell me how many dots do you have, or how many, like what's filling up how many things are filling up the histogram bins, and what would the applet do to add one more dot to the graph? Okay, so do that. Then B, describe the shape of the distribution of sample means. How does it compare to the shape of the population? So that's 2 questions there, so answer both of them. C, what does the mean of the sampling distribution of sample means? How does it compare to the mean of the population? So thinking about your answers could be less than, more than, or about the same. If they're almost the same number, then say about the same. And then for D, what is the standard deviation of the sampling distribution of sample means? How does it compare to the standard deviation of the population? So again, it should be less than, more than, or about the same. So tell me which of those it is. Number 12. Does simple random sampling for quantitative data appear to be an unbiased sampling method? How are you deciding? This is using stuff from last section again. So hopefully you have a good understanding of what does it mean to be biased or unbiased and why. So show me that in this question. In 13, suppose we wanted less sample-to-sample variation in the sample means. What would you change about the sampling process? So in this case, if we're choosing randomly, there's only a few things we can change, and they're mostly up there. So we're about to get to that in a second. So the key idea is that when taking random samples, the distribution of sample means will be centered around the population mean mu. So this histogram of the sample means is going to be centered around the center of this guy, or the original. And then the standard deviation is going to be the population standard deviation divided by the square root of n, where n is the sample size. And it'll be approximately normal if the population is normally distributed, or if the sample size is large enough. And we'll give you some rules of thumb for that, but I think we're not ready to give you a rule of thumb for that yet. Okay, so number 14 says use your applet to output to verify the standard deviation. So here, I've got a standard deviation of 0.949. and the original standard deviation was 2.119. And I'm doing samples of size 5. So if I pull up my handy dandy calculator, I need to do 2.119. This is sigma, the population standard deviation, divided by 5 square root. Now you do it, I'm doing it with order of operations is my calculator, because see how it's my number divided by square root of 5 now. So I press equals and I got 0.947. And then look over here at the sample statistics. That distribution is 0.949. Look at that. Mine are almost the same number. Maybe yours will be too. All right. But your number might be slightly different from mine because of randomness. Okay. So next, you will change the sample size from 5 to 10. Predict how this impacts the shape. So what's going to happen with this shape of this thing if you move it from 5 to 10? So give me a good guess there. Now generate 10,000 random samples of 10 words. So, okay, so we need sample of size 10. Maybe I need to go over here a little bit. Okay, and then I need 10,000. 10,000. Draw samples. Okay. And so now, here's my distribution after 10,000. So using what you've seen so far, what is least likely? So for number 17, that's the last question of this. And so which of these three, 1, 2, or 3, is the least likely? And then the key is explain your reasoning. So tell me why each of those is, like, whichever one of those is the least likely. All right, that completes the discussion and hints for this worksheet.